Hey guys, so this video is just going to be a review of the midterm. I emailed you guys all your midterms, and essentially you should be able to print them out off of your college email address, and then if you wanted to watch this video and see and check your answers, you would have the opportunity to do so with this video. So I'll try to do this as quick as I can. So starting with the first page of the midterm, you've got your New Jersey tolerances, which at this point you should all know, but it is important to know that when you get down into the horizontal prism, that you got 0.25 each eye, 0.50 total, and then if it's less than or equal to 0.50, the PD, the total PD should be less than or equal to 4 millimeters. If it's just greater than 0.50 total, then the PD can be less than or equal to 2 millimeters. On the vertical, it's 0.25 each, 0.33 total only, with no exceptions. We get to the second page, which starts our problem where we're trying to determine if the glasses pass or fail for New Jersey tolerance. The only answer that's really on this sheet is that the OD will pass for axis, will fail for axis tolerance because it was given at 68, came in at 70. It was a 1 1/4 sill. 1 1/4 sill can only be off 1 degree. This one's off 2 degrees. Therefore, it's going to fail. The left lens came in at 113. Ordered at 115, came in at ordered at 113, came in at 115. Therefore, it's 2 degrees off. It was originally a 75 sill. 75 sill can be off 2 degrees. It's off 2 degrees. Therefore, it's going to pass. Going into the very messy sheet that I have here for power tolerance. The original power for the right eye, the sphere was off 1/8, the sill was off 1/8, the total's off 1/4, so we have a situation where it's pass, pass, fail, so therefore it fails. The left lens, which was sphere off 1/8, sill off 1/8, the total power was the same, all three pass, so therefore it passes for power tolerance. Then we get into the prism. Now, if you can follow this sheet, great. You guys should have your own notes as well. But when it comes to the end result, you should have had 0.09 diopters of base in prism for the right eye in the horizontal. You should have had approximately 0.83 diopters base out for the left eye. You should have had 0.091 of base up for the right eye vertical, and the left eye 0.36 diopters base down in the vertical. When we then add all those together, you should have had approximately 0.74 diopters of unwanted horizontal prism, which means that we're over 0.5. The total PD, which to go back for the previous sheet for a second, was originally ordered at 63. It came in at 60. Therefore, the PD is more than 2 millimeters off, and it's over 0.50, so therefore the horizontal would fail. And then in the left eye, we would have 0.36 and 0.09 that would compound because we have up and down prism to 0.45, which means it's going to fail because it's more than 0.33. Next question. Please give me the minimum blank size for the ODOS for the tolerance job where the lenses have even made cutout. Your decentration should have been 3 in and 4 up, 2 in and 4 up, with minimum blank sizes of 62, 64, 60, 64. All of those, going back to the original sheet, are less than 72. So therefore, both would have passed for tolerance on the making the cutout. To the next page, give me the resultant prism, scribe prism in the following RX. So you should have ended up with, and I think everybody did a pretty good job here, somewhere around 6.15 at either 26.56 quadrant 2 or at 153. The left eye should have been 6.18 at 75.96 quadrant 3 or 6.18 at 255. The one down here at the bottom, which a couple people unfortunately didn't do completely, and you can even see me, I made some mistakes myself, but 5 examples of lens material, somebody threw in a random one, but these are the exact numbers for the materials I have, and then their corresponding speeds of light. At this point, everybody should have got those. I don't have them written down here, but for frame misalignments, anything and everything we've been talking about, if you didn't get those, then please review them in the book. On to the true-false. It should have been true. A minus power lens moved in open air will move the image you see in the same direction as you're moving the lens. False. 50-50 bevel is the best choice for a -9 RX lens. You wouldn't want the bevel in the middle on a heavy minus. We would want it more to the front. True. High power lens will almost always need a 1/3, 2/3 bevel placement, even though we usually put a 50-50 bevel on plus lenses. This is sort of an ambiguous question, and I think I might have given you guys credit for this. I meant high powered, like being very strong, and even a high powered plus, you can't put a 50-50 bevel. You need it more forward so you don't have too much material sticking out of the front. Next one's false. True, true, false. I'm just going to kind of skip through these. Any questions, we can talk about it in the discussion board. We then go on to, this should have been a patient with an RX of -7 should avoid a frame with too much curvature because the base curve would be too steep. If I asked you to check the edge or center thickness, you would use the sizing calipers. I gave a lot of room on those answers. Before you finalize, the glasses are completed. You must make sure that the barrel on all metal frames is completely closed. When clocking, measuring, reading, any number of things people put in here I was looking for there. You get a positive number. And then we've got false, true. This one I pretty much was a poorly worded question, so whether you put true or false, I give you credit for it, but technically the answer should have been false. And then false, true, false, false, false. You got true, false. I don't have any answers here because I said, please list for me 4 optical tools. You literally could have listed about 15 things that we've used in the lab. I would have taken anything from lensometer to edger to all the hand tools to the lens clock, anything. 10 options that exist for patients in today's optical market. A whole host of things from every type of lens option, transitions. Everybody pretty much did okay with this. This extra credit question. Now, I know a couple of you aren't in the field, but for everyone that is, you really left a lot of points out there, and I was trying to give you guys some opportunity to make some extra points on a difficult test. But some of the things I put is, you can always ask the patient about getting a new exam. It didn't say anything about how old the RX was. You could check his old glasses against the new prescription he walked in to see how big of a difference was. So that way you can consult the patient on what they may or may not be experiencing with the prescription change. You can check old lens materials that he may have had in his previous glasses. Check his PD, his OC height, any coatings, lens designs. So that way you want to try to mimic as much as you can. And if you see something he had that was really poor or really great, you want to try to make the necessary recommendations. You could have talked to the patient about contact lenses. Has he ever had them? You could talk about hard contact lenses versus soft contact lenses, because at his prescription, a hard contact lens would be a very viable option for clarity. Safety glasses for his boat trips. Prescription sunglasses. High quality anti-reflective coatings for his driving at night. Titanium frames, since he works on a boat also, and in construction. So if he doesn't necessarily need safety frames, you get frames that are flexible and more durable. Multiple pairs. This is a easy 2-3 pair sale for this patient because of all the different things he's doing in the high prescription. His glasses break, he's got a big problem. You've got the option of glasses for style, glasses for work, glasses for play, glasses for sport, clip-ons, wear-overs, and then of course cleaning supplies, tips on cleaning, and for some places, warranties are also a big sale. So whereas many of you got multiple points on this, several of you, in my opinion, left a lot out there that could have been added on. Then we get into these charts. Now, I know this was something that we started doing closer toward the end, but still, I felt that everybody should have been doing well on these, especially with the many times I talked about learning all the grids. Now, all your answers should have definitely just been either horizontal or vertical. We had nothing in the oblique. What's important to know is even if you don't know these charts well, knowing even one of these rings can be a big help. Like with the Topcon, the box is 1 diopter. These little hash marks are about halfway to the center from the box, so that's half. Half of that again is 0.25. If we look at this being 1 from the center, this is easily 2, because it's a little bit further. Almost equal from this point to this point is from this point to this point. And then this point to this point is equal again. So it would be 1, 2, 3. 1, 0.5, 0.25. And all of these charts, even if you don't know the numbers, it's easy to try to disseminate where the point is just based off of using common sense. So this one, the A is 0.5 up, the B is 2, and if this was a left lens, this would be base in, and then C would be 3 down. On to the next one, the Marco without the plug. This one is one of the ones that's a little bit confusing because 0.25 is really close to the center, but these gaps are further away, so that's 0.5. And then this one out here is close to the circle, which is 1, so that's 0.75. So essentially we've got 0.25 and 0.75, 0.5 and 1. So the A was 1, 2, 3 up. The B, if this was a right lens, would be 0.5 in, and the C is 0.75 down. Onto the Reichert. Again, knowing just one or two of these can really help. This one is 0.25. About twice as far as that is 0.5. And then twice as far again, we got 1, 1.5, 2, 3, 4, 5. So A is 5 up, B is half, 1.5, half, 1.5, 2. Oh, and I just realized I have a mistake on this, so I apologize, guys. This is actually 2.5 in. My mistake. Anybody who has it on their test, I will fix it and give you points. C should have been a half down. Last chart, the Marco with the plug. We've got quarter, half, 1, 1.5. Excuse me, quarter, half, 1, 2, 3, 4, 5. So A is 4 up. B is 2 in, if it was a left eye. And then C is a quarter down. Last but not least, and I apologize for this being on the yellow paper, hopefully you can see it okay, but these are your newts. As always with the newts, if you see something that's circled, it means you were really close. And if it's marked with an X, then you had it wrong. In my opinion, you were too far off. And if it's checked, that means it was correct. I'm not going to read through all these. You should be able to just look at these and compare yourself. You can always pause the video, compare. But on the base curvature, what I have here is ODOS, 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 ODOS. And I took the average base curve because if you read the base curve side to side versus top to bottom versus on an angle, you might get some slightly different base curvature if it's an aspheric lens, which a lot of these are. So on the OD, the average base curve I got was 5, 5.5 for 222, for 216, 462, and then about a 5 here. I was getting it jumping all over the place for 216, for 211, I've got an average of 3.75 for the right and 6 for the left. And for job 230, average of 5.5 and 6.62. So again, I'll just go ahead and put these back up here so you can take a quick look at them again. And you can look at your Newt sheets that I already emailed you as to what your answers were and how correct they were or were not. There will be a discussion board for all of our work for this week. Please ask all the questions you would like. Feel free to talk to one another, and I will answer any questions that I see. Thanks.